Okay, let's dive right into this explainer. Today we're unpacking a massive, literally tectonic shift happening right now in global technology. As you'll see in the infographics we've put together for you, intense geopolitical tensions have essentially catalyzed the creation of a completely parallel AI hardware and software ecosystem. We're talking about Huawei's Ascend project, often called the Chinese Shield. And look, this isn't just about building a faster microchip, it's about engineering complete technological independence.
So, here's our quick roadmap for today. 1. The geopolitical catalyst. 2. The hardware response, Ascend 950. 3. The power of scale. 4. The generational gap. 5. Market shares and expansion. And finally, 6. The future of AI ecosystems.
All right, Section 1, the geopolitical catalyst. To understand this massive hardware pivot, we really have to look at the historical events that forced Huawei into this era of radical self-reliance. It's like a cascade of catalysts. It starts back in 2018 with the arrest of Huawei's CFO Meng Wanzhou in Canada. Our source material notes this was really the breaking point, an event viewed by Beijing as a state kidnapping that essentially transformed Huawei into a national symbol of resistance. Then, moving into the pre-2020 era, you have the Five Eyes intelligence alliance raising espionage and backdoor security concerns, which, well, pretty much erased Huawei from the West's global 5G network. U.S. silicon blockade. By cutting off Huawei's access to TSMC's chip manufacturing, they essentially cut off the company's oxygen.
Section 2. The hardware response, Ascend 950.
Now that absolute blockade, it forced a radical, totally unprecedented reaction from Huawei. We're witnessing an absolute bifurcation of global AI tech. Huawei isn't just trying to build a chip to rival NVIDIA. They're building a totally independent parallel universe. Think about it. On the US side, the global stack is split up. NVIDIA designs the chips, developers use CUDA software, and TSMC manufactures the actual silicon. But inside the Chinese Shield, Huawei is vertically integrating the whole shebang. They designed it in-house through HiSilicon. They run it on their own proprietary CAN software, and they manufacture it locally through SMIC. It is a completely closed loop. And the really crucial point here is this staggering performance claim, 2.87. Huawei's newly mass-produced Ascend 950 PR reportedly delivers 2.87 times better inference performance than NVIDIA's sanctioned H20 chip. And get this, it does so at roughly 1/4 of the cost. For Chinese hyperscalers running massive models like DeepSeek V4, that is brutal, undeniable math, heavily favoring cost leadership.
Moving on to Section 3, the power of scale.
So how does Huawei build on that foundational hardware? Well, there is a massive disparity in manufacturing right now. Because of the sanctions, Huawei's domestic partner SMIC is stuck at a 7-nanometer process. Meanwhile, TSMC is out there pushing the boundaries of 2-nanometer tech. That's a lag of 2 to 3 entire generations. So the big question is, how does a company compensate when they're stuck with older, less efficient manufacturing tech?
Well, here is their brute force solution, 8,192. Huawei is stringing together an incredible 8,192 Ascend 950 chips into a single massive cluster known as the Atlas 950 SuperPod. They are essentially relying on pure, massive clustering scale, using sheer quantity to make up for the lack of cutting-edge manufacturing quality, just to rival the total computing power and memory capacity of flagship NVIDIA setups.
Which brings us to Section 4, the generational gap.
Hardware is really only half the battle here, you know? The software ecosystem acts as a massive barrier to entry. The research highlights a pretty heavy reality they call the digital prison. See, while Huawei's proprietary CAN software is rapidly improving and adding better compatibility tools, migrating away from NVIDIA's industry-standard CUDA software is incredibly costly. It's complex. If a developer or an enterprise completely switches their stack to Huawei, they risk entering this digital prison, meaning they effectively leave the global AI ecosystem behind. It's a massive, critical commitment.
Let's check out Section 5, Market Shares and Expansion. Despite those severe migration risks, let's look at exactly how Chinese hyperscalers are reacting to this cost-performance proposition on the ground. The market share shift is, frankly, staggering. By 2026, Huawei is projected to capture anywhere from 35 to 50% of the local AI accelerator market, surging to become the absolute #1 domestic supplier in China. Meanwhile, NVIDIA is plummeting to around 8% due to those export restrictions. We're talking about massive adoption here, fueled by orders like a reported $5.6 billion from tech giants like ByteDance. But here's the kicker.
They aren't stopping at their own borders. A really critical strategic move is their expansion into South Korea in Q4 of 2026. Huawei is launching its Ascend 950 hardware and SuperPods through local distributors. Why does this matter? Well, because South Korea is a Western allied market. This move serves as the ultimate litmus test. Can Huawei's massive cost efficiency and tailored localization actually overcome the deep geopolitical sensitivities and security concerns of a friendly global market?
Finally, Section 6, the future of AI ecosystems.
This really brings us to the overarching reality of what this means for you, whether you're an investor watching market shares, a developer choosing a stack, or an enterprise decision maker mapping out future tech dependencies. To summarize the strategic dilemma we see in the data, Huawei offers unparalleled cost leadership for inference workloads, incredible vertical integration, and a massive government tailwind pushing for domestic substitution. But, and it's a big but, doing business here means accepting a generational single-chip performance gap, taking on those steep software migration costs we talked about, and navigating extreme geopolitical isolation and supply chain volatility.
So as we witness this unprecedented technological decoupling unfold right before our eyes, a critical question remains. As AI infrastructure scales, will this Chinese shield remain an isolated, localized workaround? Or will pure cost efficiency force a permanent, multipolar fracturing of the global technology supply chain? It's a fascinating, complex reality, and definitely one we're going to be watching very closely.